caffeine there. I want to go ahead and fill in any missing lone pairs. Notice how the question, or the compound itself is not showing any non-zero formal charges. So you can go ahead and assume they're all non-zero. So those kind of things have to explicitly be shown in their structures. So if they're missing, it's implied to be zero. So I'm going to go ahead and fill them in. We know that oxygen having a zero formal charge, if it has 2 bonds to it, how many lone pairs? Should have 2. Yep, 2 lone pairs, so 4 electrons total. So 1, 2, and then same deal for these guys over here. And then what about nitrogen? Should have 1. Yep, 1 lone pair and 3 bonds, typically, if it's happy. And this one right here might look a little bit different than what we're used to, but it still has 3 bonds and the lone pair. All right, next thing I could ask here, just getting some practice here, would be what kind of functional groups are present. I'm actually seeing a lot of the same one. The one I'm referring to is the one that has nitrogen and the carbonyl. There's actually a couple of these in here. So this is the way you would want to answer it. So those 3 are actually the same functional group. Which functional group is it? It's the amide. So all 3 of those are amides. And what was the other name that I mentioned about those? Peptide was the other name. Okay, and then what about this piece right there? What is that? What was that? Amine. And it is an amine. So additionally on top of that, I could ask, is it primary, secondary, or tertiary? That is a tertiary amine. There are 3 carbons coming off of it. So that is, I'm going to be, I like to be as specific as I can. So that is a tertiary amine. This one is not one of the ones on the list. The ones that are not on the list, I'm not too worried about that I didn't cover. But in case you're wondering, this is an imine, I-M-I-N-E. That's when you have a double bond at end. But that's next semester stuff. So don't add it to your little list of things to study, what I'm getting at. All right, and that's caffeine. I'm sure you guys are getting plenty of caffeine intake now, right? with this class. All right, and then if caffeine not doing it for you, and you've been, giving yourself a headache, we got things like naproxen on there. So let's take a look at the functional groups. I am seeing, I think there are 3 functional groups in that compound. What do you guys think? I heard carbox, or that carboxylic acid. That's this end over here. For the sake of time, I like to abbreviate them as C acid for short. And then what else is there? There is not an aldehyde. There's an ether. That's this right here. And then one more. The aromatic ring. And this actually goes all together. That whole piece there is aromatic. Right. For the next one here, before I start circling functional groups, I want to ask the question is, what is the IHD for that compound? What's that?
C or B?
We're looking at C. Yeah, so I want to go ahead and do part C here, but before I do the functional groups, what is the IHD? It's 9. So how did you count it directly, or did you get the formula first? You want to just count it, yeah. So I did give you guys an equation, and if you're being asked what is IHD and you're given a formula, the hard way is to determine the formula then calculate it. That is the hard way. The easy way is just to go ahead and look in there and count it. So you want to basically just count any rings or double bonds. So the benzene ring is 4, 5, 6, 7, 8, 9. Also notice here how that piece right there, how it looks kind of funny. The way it's drawn with the bold lines, that's basically a big wedge coming out of you. So the whole ring is coming out at you. And that's typically how we'll represent a 3-dimensional ring. They're kind of like coming at an angle towards you. What's that? Yeah. So this benzene ring, we have the ring and then the 3 double bonds, so that's 4. And then 5, 6, 7, 8, so that's all the different rings here, and then 9 is that double bond right here. All right. So I want to go ahead and do functional groups now. I'm counting, there's quite a few in there. Let's go ahead and just take a look at, notice here, I want to go ahead and circle that whole thing. So that's the benzene ring with the OH coming off. So I did specify to you guys that we should try to avoid having a double bond to C with your OH. I did say then that there is an exception to that, and this is the exception. It is okay to do that with phenol. And so this is a benzene, aromatic. It's also an alcohol, but we typically put that all together and just call it a phenol. Either way is correct. But if you're naming it separately, make sure you circle the pieces separately. Or if you see a benzene with an OH on it, circle the whole thing and just call it a phenol. And that's what we call those. All right, what do you guys think this one is? That is an ether. And I am seeing 3 more. There is another alcohol. So there's an alcohol right here. And then what else is there? There is an alkene. It is right here. And the last one, it's an amine, but I want to be specific here. This is a tertiary amine. I did want to show you guys, I have this molecule drawn out on paper here. I just wanted to show you something. So there we have the structure for morphine. Do you guys know what morphine is commonly used for in the medical field? Or it's for typically for severe pain relief, right? So it turns out that if you start taking, or if you look at the base structure here, like this piece, like all that ring structure, that's what's called an opioid. So anything that has that basic structure there is an opiate. So we can actually, morphine is the most commonly occurring natural form of opiates. And we can actually do subtle tweaks to the molecule and it makes it different drugs. So for example, I think one of the simplest transformations that people do is you can get rid of this OH, and we can do what's called an oxidation. You remember oxidation reduction? Don't worry about this now. I'm just talking here. But if we do that, turn that to a double bond O, that is an oxidation, and then get rid of the double bond that is a reduction. We have this, and that is now the structure of Dilaudid. You guys know what Dilaudid is? It's even stronger than morphine. So they give this stuff to you for, like you just came out of surgery. From what I understand now, though, from talking to people that work in pharmacy, you can actually get Dilaudid in pharmacies now, which I think is kind of ridiculous. All right, so I want to go ahead and bring it back to what it was, just to show you something else, another drug. So this was a dash. So we can do another reaction. It's called an acylation. And that's basically converting the OH to a ester. So we have an ester group there. And it turns out that it'll actually make an ester everywhere there's an OH. And so there's another ester over here. That is heroin. So showing you, and the chemistry to go between these is actually super easy. So, I mean, a lot of people think like, oh, that drugs are hard to make because they're illegal, but honestly, chemistry does not care about the legality of things. This is actually very simple chemistry. And that's actually really kind of crazy because if people get their hands on this stuff, it's actually super easy to make other things. And we're actually going to go through the step-by-step synthesis of methamphetamines probably next semester, and you're going to see how easy that chemistry is also. You guys are going to learn all about drugs and how to make them, and the reason why I put an emphasis on this kind of stuff is because most of you guys are going in a field where this is relevant. Like most of you guys are going into medicine, pharmacy, that kind of stuff. And my hope is that you guys will get a connection between the chemistry and the real world that's happening. And chemistry is what's actually happening here. All right. With that in mind, I have another example here that is not on your little handout. It's Sildenafil. Does anybody know the common name for that drug by chance? That is Viagra. Yeah. So I want to go ahead and pick out the functional groups. There are actually 2 of them in there that I'm seeing that are not part of the list. So if there's extra ones in there, don't worry about studying the extra ones. I already gave you the ones that I want you guys to know. And I also wanted to mention here too that if you actually Google functional groups, I probably gave you a third of what's actually out there. If you look at all the different possible functional groups, organic chemistry, yeah, it's roughly a third that I gave you. All right, so let's use green for this one, just for funsies. So I am seeing a couple amines. I am going to circle all the amines. And how many do you guys see? I'm hearing 5, 4. Is the green on 5? All right, let's go ahead and circle them all. So I'm seeing 1 here, 1 here. There's 1 here, 1 there. And I don't think, so this one here is not an amine, that's an imine. So we're just going to go ahead and ignore double bonds to end like that. And this one here is an amide. So this one here is tertiary amine. Oop, keep bumping this camera. I would argue this is also a tertiary amine. It's kind of muddied a little bit because we have the sulfur group there. And then this one is that, what do you guys think? Is that tertiary as well? Nope, that's secondary. It only has the 2 bonds there. And then this one here is also tertiary. All right, I'm not going to bother circling the imine or the sulfur group because I don't want you guys to focus on that stuff. I am seeing 3 more, though, that were on the list we went over last time. Oop, there is an alkene. I missed that. Yeah, it's right here. I didn't even notice that one. Yeah, that's an alkene. Good call. All right, so I'm saying 3 more now still. What's that? The ring. Yep, that is your aromatic ring. This is go ahead and just call it benzene for short. And then what else is there? Yep, there's an ether over here. And 1 more, I believe. There's an amide. It's right here. Oop, that's AM. Whatever, close enough. All right. So this is the kind of thing that I want you guys to be able to do when recognizing functional groups. That if you had a molecule, you can kind of pick them all out. I do want to point out that in your biology classes, they may have had you guys point out methyl groups. We don't do that. We don't consider those functional groups here. So don't worry about those. Don't worry about the alkanes. Worry about everything else. All right, the last example I wanted to do here is Daraprim. Does anybody know what this drug is? This one was actually all over the news about a year ago. You had the Bond villain, Martin Shkreli, right? You guys remember that name? Those of you guys going to pharmacy should really know this name. There was a guy that he bought out the patent, or he had to own the patent for, huh? Basically, he owns the rights for Daraprim, and he hiked the price up to like $3,000 a pill. Yeah. And this actually had huge impacts on South Africa because they can't afford it. So the thing is about compounds is that you can actually get patents, and you own that structure. So if it happens to be some drug that's saving lives, you can take the dick route and charge people for it, or you can take the nice route and just make profit off it. Honestly, if he would have sold it for like $1 a pill, he'd still be making a killing off this stuff because it actually ends up being dirt cheap if you make a ton of it at a time. But yeah, he raised the price of these like to several grand per pill. And thankfully, our FDA kind of stepped in and really put a lot of pressure on him to lower the price. They basically convicted him of other crimes that he was doing to basically get this price to come down. And honestly, if you Google this guy, he looks like a complete prick too. So, and I don't even feel bad talking about him on YouTube. He can come at me, whatever, dude. He's a complete prick. But yeah, that's there for him. I'm pretty sure I'm not the first person to say that about him. He's just a farmer, bro. That's what he said too. I'm a farmer, bro. You guys know what it's like. Like, no, I think people's lives are more important than dollars are. Anyway, I want to go ahead and pick out some functional groups here. Notice how these ones are kind of embedded into a benzene ring. One way we talk about those are pyridines. And you guys may have heard like your purines, pyrimidines, all that stuff from biology, like those nitrogenous bases. A lot of those are actually aromatic rings with nitrogen embedded into them. We're not going to worry about that in this class. So I just want to pick out the ones that we talked about. So we have some amines in there. I'm thinking 2 amines. And there's one here. And is that primary, secondary, or tertiary? It's primary. And then so is the other one. All right, and we see that, and we also have that. What do you guys think? What the ring is what? Benzene? Aromatic ring. And then what is the one with the chlorine? What do we call that? Alkyl halide. Yep. Or if you want to be specific, there's actually a couple ways we can talk about this. We can call it another name for a benzene ring is an arine. And I've heard people call it like arine halides or arine chlorides. That's all like tomato kind of thing. There's a lot of if you're studying this stuff by looking things up online, you may see different names for the same things, and it's all just part of the language here. Anyway, I'm going to go ahead and just call this the simplest term, which is an alkyl halide. But if you see the word arine with that, that is perfectly fine as well. All right. So I have or any questions about functional groups at all yet? You guys seem like you're getting it down. So if you're having trouble with any of these, that's the kind of problems that you want to do to become good at it, is take a look at compounds and try to pick out all your different functional groups. All right, the next problem type I want to work on here is resonance.